some supplementary problems, and we're not going to solve all of them, or maybe we might solve all of them, but we might not solve all of them. We will solve some of them, and then you practice the other one. So we're still on chapter 1, and chapter 1 involves antiderivative, sigma notation, areas, finding areas under the curve, indefinite integrals, and the definite integrals. So for the indefinite integral, we're going to do just the elementary portion of it. The definite integral, also going to do the elementary portion of it, just to show you the difference between the definite and the indefinite integral. Then when we dive into chapter 2, which is methods of integration, you're going to see how we will actually be applying the definite and the indefinite integrals. So let's look at a few of these supplementary problems. We have question 1, which says that, let's do it right here. You have question 1 says the summation of the square root of r as r reads from 1 to 5. Now the direction said we must write each in expanded form. Now we were not asked to find the sum, we were asked to write in expanded form. So to expand means to just open up, not to add them up, but to just open up. So remember now, when r leads from 1 to 5, it means you must replace this summa. Remember I told you this is the summa, this entire expression here is the summa. So replace this summa now with the lower bound, starting with the lower bound. So we start with 1 plus the root of the same r should be here, but we move to the next number. From 1 now, you know, go to 2 plus the square root of, from 2 now we go to 3 plus the square root of 4 plus the square root of 5. So we have written in an expanded form. We do the next problem. The next problem says the root of, let's say the summation of 3 raised to the power r as r leads from 4 to 6. Again, it's just simple. We take 3, we replace this r now with 4, plus we take the same 3, the base, we replace the r now with the next number. This first one is 4, the next one is 5, plus 3, we replace this r now with the next one, which is 6. We have arrived at the last expression. So we move now to the third question. The third question says the summation of 2k minus 1 all over 2k plus 1 as k leads from 0 to positive 4. So this is also similar. We expand this. So wheresoever we see k, we put 0. So it's 2 times 0 minus 1 all over 2 times 0 plus 1 plus from 0 now 0, 1, 2, 3, and 4. From 0 we move to 1. So you have 2 times 1 minus 1 all over 2 times 1 plus 1. From 1 again we move to 2. We have 2 times 2 minus 1 all over 2 times 2 plus 1. We move to 3. 2 times 3 minus 1, 2 times 3 plus 1. And then lastly we move to 4. 2 times 4 minus 1, 2 times 4 plus 1. So we simplify now. So therefore we will have, this is 0 now, this is 0. So it's just minus 1 over positive 1. Negative divided by positive is negative. So 1 over 1 now is just 1. Plus 2 times 1 is now 2, right? Minus 1 all over 2 times 1 again is 2 plus 1. So this is 2 minus 1 is 1 all over 2 plus 1 is 3. So it's 1 over 3. Plus 2 times 2 is 4. 4 minus 1 is just 3. 2 times 2 is 4. 4 plus 1 is 5. So we have 3 over 5. 2 times 3 is 6. 6 minus 1 is 5. And then 2 times 3 is 6. 6 plus 1 is 7. 2 times 4 is 8. 8 minus 1 is 7. 2 times 4 is 8. 8 plus 1 is 9. So this is the expanded form of this expression. Now let's look at question number 4 and the rest of the other problems. So remember now the direction says that we must expand each of these. We should not find the sum, we should just expand it. So this one, the summation of r to the 10th power when r leaves from 1 to n. So it is this r that you are changing. This 10 remains constant. So when r is 1, we're going to write 1 raised to the 10th power, plus when r is 2, you're going to write 2 raised to the 10th power, plus when r is 3, you're going to write 3 raised to the 10th power, plus when r is 4, you're going to write 4 raised to the 10th power. Now, no matter how long you go, you are not going to end because this is the nth power. You do not know the nth power. So we just express it like dot, 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 plus, then we now say n raised to the 10th power. So this n now represents the last expression. The next one, question 5, says the summation of minus 1 raised to the power j as j leaves from 0 to n minus 1. So in the expanded form, we have minus 1 when you have j to be 0, plus the next one you will have minus 1 raised to the power 1, plus minus 1 raised to the power 2, plus dot, dot, dot. You're not going to end until you reach to the last one, which is now n minus 1. So therefore, if you further simplify this thing, any expression raised to the power 0 is just 1. Now, when you have, let's say, negative raised to a power that is even, it gives you a positive result. When negative is being raised to a power that is odd, it gives you a positive result. Now, what do I mean by that? If you have negative 1 raised to the 3rd power, this is odd, it will be equal to minus 1. If you have negative 1 raised to an even power, which is 2, it will give you positive 1. So even if this was negative 1 that is being raised to the power 7, 7 is odd, so it will be minus 1. Minus 1 raised to the 9th power, 9 is odd, it will be minus 1. Minus 1 raised to the 10th power, 10 is even, so it will be positive 1. So likewise, minus 1 raised to the 1st power, 1 is an odd number, so it will give us minus 1. Plus, minus 1 raised to the 2nd power, which is even, it will give us positive 1. So the sign will be alternating, like say positive, negative, and so forth. Plus, dot, 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 plus minus 1 now raised to the power n minus 1. So this will be the expansion. So let's do quickly the next one. We have question 6 to be the summation of 1 over j plus 1 as r now this r plus 1 as r leaves from 1 to 6. So what do we have? We can expand this thing now. We have 1 all over. We start with 1. R is 1, so it's 1 plus 1 plus 1 over 2 plus 1 plus 1 over 3 plus 1 plus 1 over 4 plus 1 plus 1 over 5 plus 1 plus 1 over 6 plus 1. So if we further simplify, we have 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7. So this will be the expansion for this one. So question number 7 now. Again, we just arrange it in the expanded form, no finding sum. So now r leaves from 4 to 6. So when r is 4, you have 4 raised to the 3rd power. When r is 5, you have 5 raised to the 3rd power. When r is 6, you have 6 raised to the 3rd power. So this is the expansion for it. Right? That's the expansion. So the next one says the summation of x to the power k leads from 5 to 8. So this now, when k is 5, so x remains x, k now is 5 plus x when k is 6 plus when k is 7 plus when k is 8. So this is the expansion. Now the next one here, you have question 9 that says the summation of j cubed when j leads from n all the way to n plus 3. So when j is n, you have n raised to the third power. When j is n plus 1 raised to the third power. When j is n plus 2 raised to the third power. Now when j is n plus 3 raised to the third power. And then question 10 now, you have the summation of f of x sub r times change in x sub r as r leads from 1 to n. So you just take the first three terms, you have f of x sub 1 change in x sub 1 plus f of x sub 2 change in x sub 2 plus dot dot dot. Then we take the last one when r now is n. You just going to say x sub n times change in x sub n. So this is just the expansion for it.